All right, we start this video lecture with a bell ringer. Pause it after I ask the question. I'm going to answer the question right after I ask it, so make sure you pause it and give yourself some time to think. So what's the difference between erosion and deposition? 1, 2, 3. You should be able to identify that erosion is the moving of sediments from one place to another, while deposition is the dropping of sediments. So deposition can happen without erosion, but so the two are closely connected. Erosion, movement; deposition, dropping. True or false, chemical weathering changes the composition of a rock. 3, 2, 1. This is true. Chemical weathering does change the chemical composition of a rock. True or false, frost wedging is an example of chemical weathering. 3, 2, 1. This is false. Frost wedging does not change the chemical composition of the rock, so we know it is an example of mechanical weathering. Our challenge question: what is an example of mass movement? Let's figure that out today. So you're going to need your mass movement notes out, and we're actually going to talk about mass movement, wind erosion, and glaciers today because they all tie in together. The key or the tying factor, the moral of the story or the lecture today, is that sediments can sometimes move in a mass or a big, large chunk. Think avalanche, mudslides, landslides, glaciers pushing a bunch of earth out of the way as they move. That's what we're looking at today. Let's start again, and a reminder: erosion is the process by which the products of weathering are transported. So for this, you're going to use your fill in your blank notes. You'll fill in the blanks as we go along. You're going to have to pause this lecture. I can already feel it because we're going to try to get this lecture in 15 minutes. But that's the beauty of having it pre-recorded. You can pause and play when you need to. Some examples of erosions or methods of erosion causes are wind. The wind picks up sediments and moves it from place to place. Gravity. If a sediment is falling off the top of a cliff, gravity is moving that sediment. Glaciers. Glaciers can move. Glaciers are ice. They can move sediment from one place to another. Ocean, waves, currents, and streams. Any kind of water can also pick up sediments, as we know, and transport them from one place to another. Again, this is transporting the products of weathering. So our sediments that are weathered away from larger rocks. This is a beautiful example of what erosion can do. This rock was most likely eroded by the waves as the tide came up and eroded that lower part of the rock right there, leaving the upper part still intact. Very beautiful. This is also how we get the arches, and I think we'll look at some too. So you'll see in a second. Mass movement, before we get into too much of our products of erosion. Mass movement, as the name suggests, is the movement of rock fragments down an incline as a result of gravity. We are going to study 4 types of mass movement today. They're all in your notes. We've got pictures of them. We'll describe them, and just a vocab word to introduce you to: talus, which is a pile of rocks that accumulate at the base of a slope. Let's look at those 4 types of mass movement. Mass movement, by the way, doesn't have to be quick and deadly and dangerous. It can be slow and less dangerous, but oftentimes even the slow ones can be dangerous. So they don't have to be quick, although you're going to think about the quick ones like the landslides and mudslides, but they don't have to be. They can take a long time for the processes to fully happen. Just know that they are a large pile of sediments or rocks moving. We'll look at it in a second. That's a hard thing to define without knowing the other terms. Let's talk about landslides first. Landslides are a sudden movement of loose rock and soil down a steep hill, mountain, or cliff. Landslide, avalanche is what we call it sometimes as well. That's our last point right there. Landslides are often caused by heavy rainfall. The rain soaks up, or the water soaks in between those soil particles, making the soil more turbid, more liquidy than normal. Because they're liquidy, they'll be a little bit more loose, which means that the gravity of the earth pulling on the land is stronger because they're looser, they're more wiggly. Spring thaws can also cause landslides as the snow and ice melts on top of the mountain. The water or the runoff can pick up sediments as it goes, or it can cause big chunks of land to fall off the side of the mountain. Volcanic eruptions or earthquakes, anything that is causing vibrations within the Earth's crust, can also cause some landslides. Let's look at some pictures. There's an example of a landslide. Landslides, as you can imagine, are very dangerous. They're often quickly moving and not always expected. So you can see the land slid off the side of the mountain and ran into this town right here. One of our projects is for this unit is going to be to predict the probability of these geological hazards happening and talk about some safety things that we can do to help prevent those. But that's another day. So that's an example of landslide. A creep. Creeps are slow, so I would highlight, underline, star, indicate in some way that slow is important. They are the downhill movement of rocks and soils. It causes fixed objects such as trees, fence posts, light poles in the soil to lean downwards. You can see this tree is leaning downwards, so at one time the tree stump, the tree base, there's the word, might have sat right here, but as time moved on and the land started to creep slowly downwards, the tree started to bend. Because this is so slow, it usually goes unnoticed until objects begin to lean. Some of the causes of this, again, are excess water in the soil. Anytime we've got excess water or the loosening of soil, we're going to get mass movements of land. We want our soil tightly compact. Burrowing animals can also loosen that soil, and alternating freezing and thawing can loosen the soil and rocks as well. We talked about the alternating freezing and thawing. We could have some frost wedging in there, making some of our rock sediments become loose. Here's a diagram of what a creep might look like. Again, they're very hard to identify at first because they're so slow, but eventually over time we're going to get this sideways leaning of our fixed in place structures like trees and light posts and even fence posts right here. A slump. A slump is a loosened rock and soil that moves downhill in one large chunk. So while our landslide over here was a bunch of sediment kind of following each other, so this wasn't very tightly compact at all, our slumps are compact. This again is caused by excess water in the soil, which causes a loss of friction, allowing rock to slip downhill. You can see this on a large scale, but you can also see this on a small scale as well. We'll show you in a second. So here's a slump on a large scale. You can see this area right here at one point must have experienced too much water in the soil, which would have loosened it, and it fell in one great chunk. Again, we've got damage to property and possibly human life right here as the land covers some of these houses. So these, again, are very dangerous things. Here's it on a small scale. The road right here slumped or washed out is one of the ways we say that. The big chunk of ground right here experienced too much water and all of a sudden fell over the side. Last one is called a mud flow. So this is like a landslide, but it's mainly clay and silty soil saturated with water, so it's really mud, like muddy water with a little bit more mud than water, and it's going to rapidly flow downhill. This is really dangerous too. This is caused by heavy rainfall. It usually occurs in dry mountainous regions during sudden heavy rainfall, so when we don't expect a lot of rain is when it's going to happen, or when we, in an area that usually has a drier climate, experiences odd rain. Might be when we would experience mud flow. Again, this is really, really dangerous. It can wash out roads and destroy buildings and possibly, again, damage human lives. Here's an example of a mud flow. You can see the mud flew, not sure what the verb there is, but it flew all the way around, and this is the second story of that house, so the mud is completely covering the house. This is a roof of a second house. Very, very, very dangerous, busting out these windows going into the house, and hopefully whoever was living either evacuated or is on that second floor right there, perhaps safe and out of the way. So again, dangerous. So some of the things we've done as a society and as geoscientists is to find ways to stabilize the land. And we don't see this very much here where we live because we live in the coastal plains, so we don't really have very many mountains or hills, but this is a common thing to see up in the mountains of North Carolina towards the western part of the state. These are strategies to prevent the mass movement of soil and land because they are deadly and at the very least damage property. So we want to take as many precautions as we can to try and prevent them. Some things we've done to try and prevent them are concrete retaining walls, so building walls around really steep sides, retaining bolts, drainage pipes to reroute water, so we know that excess water causes a lot of these issues. Let's try to get the water out of there before it can do damage to the soil. We can grade the slope, so instead of making it very, very steep, we might build it out so it slowly slopes down. And we also use explosives to try and cut down on this possibility of having mass movements. We could use explosives to get rid of the hill altogether, although that's not a very sustainable option there. We can use explosives to reshape the walls to better stabilize them, to make them more gradually sloping. We could do a wide variety of things with this. So here's an example of some construction workers stabilizing the road right here. They've got a mesh wire right here, but they're concreting this wall right here. So they're stabilizing the edge of the road by putting concrete on top of the mesh and on top of the soil to help keep that soil in place. We are not going to do an activity just yet. We're going to keep going with our notes, and we're going to have to do another video lecture as well. So we're talking about erosion. So this is the bottom part of your notes. Erosion by wind specifically. It's a beautiful, beautiful thing. Erosion by wind and water creates all kinds of crazy, wonderful flowing structures like this. I think definitely if I could paint better or create art better, I would try to recreate these. But I love how they seem to just flow in all kinds of odd shapes. Remember, erosion is the process by which weathered products are moved. Wind is one way weathered products are moved. We also know that they're moved by ice and water. Where does wind erosion occur? Now this is specifically important. So wind erosion occurs in places where there's little vegetation. Plants, trees, and grass, their roots help to stabilize the soil, making it harder for the wind to erode that patch of soil. Places where there's little water also can be very susceptible to wind erosion. Water makes the soil heavier, which is makes it harder to move by wind. So if we have wet ground, it's less likely that it's going to erode. But if we have dry ground, like at the beach or the desert, or we experience a drought, our soil has an increased risk of being eroded. Now, when we talk about the human impacts on our lithosphere, we're going to learn that the more open ground farmers leave and construction workers leave, the more erosion by wind we have on that soil and how bad that actually is for us. We only have a little bit of topsoil, or that soil that's really good for growing to begin with. So when people leave our topsoil open and bare without any plants on it or without anything covering it, it's really taken away that good layer of topsoil that we have, which is not good for the farmer because then they can't grow anything, but it's often a common problem for our construction workers as well. And then if you remember back to our hydrosphere, we learned that open ground or areas where sediment can be eroded and moved into a watershed like a river is also really dangerous because those sediments can pollute a river and cause the photosynthetic organisms living inside that river system to not be able to photosynthesize. So it's a big deal that we have this erosion by wind. We're going to finish this video or finish this lecture in another video, so hang tight for that. Have a great day, guys. You're not done yet. This is only part 1.